Good morning to all. In today's lecture series, we are going to see about the topic of how to find the efficiency of bubble sort using the mathematical analysis. The last class we saw about how the bubble sort is works. So I recollect that how the bubble sort is work. The bubble sort is a comes under the brute force design technique. So what is a brute force? Brute force design technique means we find all the possibilities, and among the possibilities we pick up the best one. So the bubble sort, we compare the adjacent elements of the list, compare the adjacent elements and swap the elements if it is which one is the maximum element. So at the end of every pass, the largest element is comes under the last position of the array. This is the way the bubble sort is works. So in that bubble sort, the algorithm and the bubble sort algorithms, what is the basic operations? The based upon the non-recursive algorithms general plan. First we have to find what is the input size. The input size here is an n. The second one, we have to find out what is the basic operation. The basic operation is nothing but the comparison of the two adjacent elements. The third one, we have to count how much time the basic operation is executed based upon the innermost loops. So based on that, we find out the using the summation formulas, we find the efficiency of an algorithms. So the efficiency of an algorithm is order of n squared. Now we will see how to get that order of n squared using the mathematical analysis. So in that mathematical analysis, we are using the majorly we are using the two summation problems. One is the summation of I is equal to 1 to n, that is executed one time, means we have to expand this summation by using that upper limit minus lower limit plus 1. The second summation problem is summation of I is equal to lower bound to upper bound, that is executed on I times, that is equal to n into n plus 1 divided by 2. So this is the two main summation problems are used in all non-recursive algorithms. So using that we can find the efficiency of any algorithms. First we have to what is the basic operations. The basic operation is the comparison. So how much time the basic operation is executed? So the C of n is equal to we are using the two loops. One is a I loop and other one is a j loop. So the I loop is an outer loop, j is an inner loop. So these two loops are executed for every time it is executed exactly once. So the summation of I is equal to 0 to n minus 2, that I loop is executed. The j loop is executed. Summation of j is equal to lower bound is 0. The upper bound is equal to n minus 2 minus I. So these two are executed in one. This is right in the first step. So after that, first step, after writing that the summations, we have to expand the inner loop first and comes to the outer loop. So based upon so the inner loop is executed one time, means using the in the two summation problem, the S1 is used in this calculation. So the what is an S1? Summation of lower bound is equal and the upper bound one time, means upper bound minus lower bound plus 1. So here the n minus 2 is a lower upper bound and I is a lower bound. So n minus 2 minus I. So the lower bound, upper bound is equal to n minus 2 minus I, minus the lower bound is equal to 0 plus 1. So after doing the calculations, the n minus 2 minus I plus 1, finally we get n minus 1 minus I. So that is the inner loop value. So that inner loop value, we have an outer loop, that is summation of I is equal to 0 to n minus 2. So we take the n minus 1 as outer. The summation of n minus 1 into summation of I is equal to 0 to n minus 1 to one time minus summation of I is equal to 0 to n minus 2 into I. So this steps is get from that, we take the n minus 1 is outer, so n minus 1 one time is executed and ith time is executed. So again we expand the so here the summation of I is equal to n minus 2 I அப்படின்னா we are using the second formula. So first take it as a first step, the first இதை எடுத்துக்கலாம். ஸோ இந்த n minus 1 into, ஸோ இதை expand பண்ணோம் அப்படின்னா we will get the n minus 2 minus 0 plus 1. So after do the process n minus 1 into n minus 1, so we get that n square minus 2n minus n. So again the comes to the summation, the second summation. So here using the summation 2 formula we can get that so what is the summation 2 formula? N into n plus 1 divided by 2. So we can here the n is equal to n minus 2. So the n minus 2 minus n minus 2 into n minus 2 plus 1 divided by 2. So in that in the previous in the first for the first specification n minus 1 square minus, so இதை expand பண்ணோம் அப்படின்னா n minus 2 into n minus 1 divided by 2. so the 2 வந்து நம்ம காமனாக எடுக்கும்போது we will get the using the mathematical formulation 2 into n square plus 1 minus n minus of இதை n minus 2 into n minus 1 நம்ம expand பண்ணும்போது we get that n square minus n minus 2n plus 2. So after simplifying all these things we can get n square minus n divided by 2, that is more or less equal to the of n square, so that is equal to the n square. So this is the efficiency of an bubble sort, order of n squared. So clearly how we get the order of n square means, suppose we are using the 2 for loop, means that 2 for loop is executed, the inner loop is executed n times, the outer loop is executed n times, so we can get obviously we get that order of n square. So using the mathematical analysis we can use the two summation problems, we can substitute in the two loops, we can get that order of n square. This is the way we can do that any mathematical analysis for like the selection sort, bubble sort, and then insertion sort, we can find the efficiency. So for every efficiency is based upon the loop we are using, that what is the lower bound and upper bound value of the loop. I hope you understand how to find out the mathematical analysis, how to find the efficiency using the non-recursive algorithms analysis. Thank you.